Welcome to section 7.4, Similarity in Right Triangles. This is geometry. And to start, here's your math joke. Where does a bee go to the restroom? If you said the flower potty, you would be correct. Okay, let's start this lesson by focusing on our objective. And that is going to be to find relationships in similar right triangles. Well, what does it take for triangles to be similar? There are two criteria. Hopefully you all remember these. One of them, the sides are proportional. Whoops. The second criteria, angles are congruent. And we have now just recently learned 3 ways to prove similarity, and these are 3 shortcuts. Hopefully you can remember them. It's going to be angle, angle, side, 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 and side, angle, side. So now let's get ready to start this new material. And the first thing I want to talk about is arithmetic means, which is simply a fancy word for finding the average. Okay, so say for instance, I want you to find the average, or the arithmetic mean, of 4 and 8. Well, you would simply take 4 plus 8, you get 12. And because I added 2 numbers, I then want to take 12 and divide it by 2, which is 6. We all know that the average of 4 and 8 is 6. But there's another average, and this is a geometric mean. And the geometric mean is the square root of 2 positive numbers. Whoops. And that came about from this proportion. If you have a over x equals x over b, and you were told to solve for x, the first thing you would do would probably be to cross multiply. So I get x times x, which is x squared, equals a times b. And then because I want to solve for x, not x squared, I would now do the square root of both sides. So I get x is equal to the square root of 2 positive numbers, in this case, a and b. Alright, so let's go ahead and try this. The example says find the geometric mean of 4 and 25. Now I don't want to just add them up and get 29 and then take that divided by 2. I want to do the square root of these 2 positive numbers. So I have the square root of 4 times 25. And 4 times 25 is 100. So the square root of 100 is 10. Which if I use this proportion, 4 over x equals x over 25. And if I solved it for x, I would still get 10. Which is not close to the arithmetic mean at all. Okay, the next one. Find the geometric mean of 5 and 30. So again, it's going to be the square root of the product of 2 positive numbers. 5 times 30. So I really have the square root of 150. And we really haven't talked about how to simplify that yet, so we can round our answers to the nearest tenth. The geometric mean of 5 and 30 is going to be 12 and 2/10. Okay, so now I'm going to take what I learned about geometric mean and apply it to similar right triangles. Well, we're going to start with this statement. The altitude to the hypotenuse of a right triangle forms 2 triangles that are similar to each other and then to the original triangle. So if you look in this picture, we really have 3 triangles. Okay, see if you can find them. Well, below here it says sketch those 3 triangles in corresponding positions. So what that means is I'm going to go ahead and sketch them so that the corresponding sides and the angles all line up. Alright, and let's start by going ahead and drawing 3 right triangles. Small, a medium, and a large one. And then we're going to label them. Okay, so the small triangle is going to be this one right here. Well, luckily for us, that's how I drew my triangles to begin with. So all I need to do is label it J, M, and L. And it's always good to check your right angle. And yes, my right angle is labeled M. Okay, so my medium triangle now. Well, that is right here. And if you look, I could just take this medium triangle and rotate it 90 degrees. And then I would have my triangle down here. Well, again, the right angle is M. And it looks like MJ is my short side. And then KM is my long side. Okay. Now, I'm going to erase these marks. And I want to do the big triangle. Right here. So M is not going to be used on my large triangle at all. I'm going to have K, J, and L. This one I would have to rotate it 90 degrees and then flip it. Alright, so in order for me to start, I'm going to start at my right angle, which is J. And if you look at the sides, it seems like JL is a short segment. So that's going to be the short side of my right triangle. And then JK, or KJ, is the long side. Okay, so those are my 3 similar triangles. And my similarity statement is going to be, let me change my ink one more time. My similarity statement is going to be triangle JML is similar to triangle KMJ, which is similar to triangle KJL. Notice that these 3 angles all line up, and same with M to J, and then L to J, back to L. So I have corresponding angles that match up, and that's how I wrote my similarity statement. Okay, now let's go ahead and try one of the practice problems. Number 1, we want to find the length of X, Y, and Z. And in order to start this, I want to draw my 3 separate triangles. So I'm going to draw the small triangle first, which is this one over here. And I'm going to label the lengths, the small leg as X, the long leg as 6, and the hypotenuse has a length of Y. Now I'm going to draw my my medium triangle. I want to make sure I put my triangles in corresponding positions. And my medium triangle is going to be this triangle right here. So my right angle is there, which means my hypotenuse has the length of Z. The short leg has got to be 6 because 6 is smaller than 9, so 9 has to be my long leg. And now I want to draw my large triangle. And my large triangle, let me erase what I already have. Is going to be the whole thing right there. So my small leg is Y. The long leg is Z. And the hypotenuse is going to be 9 plus X. I have to add those 2 together. Okay, so let's see if we can come up with a proportion to solve for one of our variables. And I do have one. If I compare the small triangle to the medium triangle, and I compare the long leg from the small triangle, the long leg here to the long leg in the medium. That gives me 6 to 9 equals the short leg in the small triangle to the short leg in the medium triangle, which is x. So I have my first proportion. I can go ahead and cross multiply and solve. 9 times x is equal to 6 times 6. Divide both sides by 9, and I get x is 4. So what I'm going to do here now with my triangles is I'm going to take out this x and replace it with 4. That also tells me that I know the hypotenuse for my large triangle. 9 plus 4 is now 13. Okay, so we're going to do the same thing, and we're going to find a proportion that we can use to solve for y. Does anybody see one? Well, I do see one if I solve for z first, so I think I might try that one. To find z, I'm going to compare the second triangle, the medium triangle, to the large triangle. Do you see the proportion that I'm going to use? Let's compare the hypotenuse to the hypotenuse. So z to 13 is going to have the same ratio that 9 to z has, long leg to long leg. And now I can cross multiply again. 9 times 9 is 9 squared. 13 times 9 is 117. And I square root. Now 117 is not a perfect square, so you'll have to type that in your calculator. And you will get 3 times the square root of 13, or approximately how about 10.8? So there's the length of z. Okay, now I want to set up a proportion to find y. So to find y, well, I can use my small triangle and my medium triangle again. Actually, let's use the small triangle and the large triangle, because I have hypotenuse to hypotenuse, so y to 13 equals 4 short leg to short leg, 4 to y. And I can go ahead and cross multiply those. So y squared equals 13 times 4, which is 52. Take the square root of both sides, and the square root of 52 is approximately 7.2. So now I have found all three variables. Okay, now I know number one was kind of a long, maybe difficult problem, so let's go ahead and try number two. Okay, we're going to do it by the same method. We're going to solve it for x, and we're going to draw out each of the three right triangles again. Alright? But maybe this will make it a little bit more clear. So this is my small right triangle, which is right here. And I'm just looking for x. I know the short leg is 6 units long, and the long leg is x. Then I have my medium triangle. And let me change my pen color. And that one is right here. Now I do not know the length of the hypotenuse. It's not labeled. But I know the short leg is x and the long leg is 10. Now I could go ahead and draw my large right triangle. But if you notice, when you draw that one, the x is not even a part of that triangle. For instance, we don't know our short leg, and all we know in the large triangle is our hypotenuse is 16 units. 6 plus 10 units long. So that large triangle does not have any bearing on this problem. Okay, I can go ahead and create a proportion using these two. All I need to do is compare the long leg in the small triangle to the long leg in the medium triangle. So that'll give me x over 10. Those two sides should have the same ratio that the two short legs should have, 6 over x. And if you notice, we're trying to find x. X is going to be the geometric mean of 6 and 10. So I go ahead and I cross multiply. X times x is x squared. I'm going to write my work over here on the right hand side. And 10 times 6 is 60. Okay, to solve for x, I take the square root. And x is not going to be a perfect integer because 60 is not a perfect square. But if you type it in your calculator, the square root of 60 is approximately 7 7/75. So there. Hopefully this problem makes a little bit more sense maybe than problem number 1. Okay, let's try number 3. Now I'm not going to solve this problem with you guys. I want you to go ahead and do it by setting up your 3 similar right triangles and label your information and use that to find y. Hopefully you'll see that you have a proportion. Okay? We're going to go over 3 and then 4 in class tomorrow. And then I'm going to teach you another way that we can do this one. Alright, so good luck.